Hello, gentlemen. So today's lesson, we're going to continue talking about operations with complex numbers. So we're going to tackle division today, and then I'm going to show you a few other tips and tricks for you. So previously we learned about complex conjugates, right? So a complex conjugate is something that's in the form of, so if we have a plus bi, okay, its conjugate has the opposite sign for the imaginary part, so the conjugate would be a minus bi. Okay. And so those two would be a conjugate pair of complex numbers. So we're going to use the complex conjugate to be able to divide and write quotients in standard form. Okay. So we want to write the reciprocal of a complex number in standard form. Okay. So write 1 over 3 plus 4i in standard form, a plus bi. Okay, so 1 over 3 plus 4i is the reciprocal of 3 plus 4i. And so we don't like to have this complex number in the denominator. So what we want to do is get rid of that. And this is similar when we rationalize denominators. If you guys did this in Algebra 2, where we didn't like to have the radical in the denominator. And it's really kind of a holdover, at least the rationalization is a holdover from when we did a lot of calculations by hand. But especially now that we have calculators, it's a bit antiquated. But we do want to be able to put this in standard form. Okay, so first thing I'm going to do is in order to get rid of this complex number in the denominator, I know that if I multiply by its conjugate, okay, I'm going to end up with some real number. So we saw that in the previous example. When we multiply complex conjugates, we end up with a real positive number. So if I multiply by its conjugate, we can get a real number in the denominator. So I'm going to multiply by the conjugate, and the conjugate is going to be 3 minus 4i. Okay. But remember, I can't really just multiply by that because that's going to change the value. So I have to multiply by 3 minus 4i over 3 minus 4i. So, and this is really just equal to 1. Okay, keep in mind that this is equal to 1. Okay, this expression here. So I'm going to multiply by conjugate. And when I do that, okay, I'm going to get, obviously 1 times 3 plus 4i, or 3 minus 4i is just 3 minus 4i. And remember, on the bottom, when we multiply conjugates, okay, we get a squared plus b squared. Okay, and now you can FOIL this, you can multiply it out. Okay, but we did that, and we saw in the previous lesson that the pattern was always it ends up coming out a squared plus b squared. So I know that this is going to be 3 squared plus 4 squared, which is just going to be 3 minus 4i over 9 plus 16. So 3 minus 4i over 25. And now we're still not in standard form, but we can break this up and call this 3 over 25 minus 4i over 25. And then that is in standard form. Okay. And so now we have something that's in this form. A, there's my A, and my B is negative 4/25 times I. Okay. All right. So moving on to the next example. We're going to divide these complex numbers. So basically division, when you have a fraction, that's basically division, right? Okay. The numerator divided by the denominator. So we want to write this in standard form. We want to get rid of this denominator here. We want to get rid of this complex number out of the bottom. And so I'm going to multiply by the conjugate of the denominator. Okay. Up here, we didn't really make a big deal about that, but it is just multiplying by the conjugate of the denominator. So I've got 1 plus 4i over 5 minus 12i. And I'm going to multiply by the conjugate of the denominator. So my conjugate is the same real part and the opposite imaginary part. So I've got 5 plus 12i and so now I can just multiply across. So up here I've got 1 plus 4i times 5 plus 12i over. Now, I know when I multiply these conjugates, I'm going to get a real number, and it's going to be in the form a squared plus b squared. So it's going to end up being 5 squared plus 12 squared. And now, unfortunately, the top, there's no pattern for that. So we will need to multiply that out. Okay. So when we multiply that out, we've got 1 times 5, which is 5, plus 12i, so do it this way, plus 20i, plus 48i squared. And all of that is over 25 plus 144. And so then come down here, we can clean this up a little. We can combine some like terms. So we'll clean this up and end up with 5 plus 32i plus, now remember, I squared is equal to negative 1. Okay, so anytime we have an I squared, this is equal to negative 1. Okay, so 32i plus 48, let's use a different color. Times negative 1. I'll put that in red since I indicated that before. And so simplify the bottom, I get 169. I'll simplify the top. 48 times negative 1 is negative 48. So negative 48 plus 5 is positive 43. So 43 plus 32i over 169. Sorry, this should be a negative 43i. This is negative 48 plus 5, negative 43. And now we can write it in standard form. That's negative 43 over 169 plus 32 over 169i. And so there we have done the division and written the answer in standard form.